Hey, welcome to my channel. Now this is my friend McKay, alright? And he said he has some question. He said an integral for me to integrate. He said I will not be able to do it, and it's way too difficult. Anyway, he's here, he's going to show that to us. Even if I cannot, some of my videos will help me to evaluate the integral. But anyway, let's just give him the pen and let him check out. Let us check out what you have for.
Actually, this integral should be a lot of ways to actually figure this thing out.
Oh, you even figured it out?
Yeah. Okay. So, Ange, I want to try this.
Okay.
It says the integral of e to power x times 1 minus sine x over 1 minus cosine x dx.
Wow. Are you sure that this thing has an antiderivative?
Affirmative.
Yeah. Elementary antiderivative?
Yes, it does.
Wow.
Crack your brain and figure it out.
Wow, okay. Let's check what we can do. Alright. Oh god. No. Huh. Wow. Okay, so we've got something to solve here. Let me write it well. We have the integral of e to power x, and then 1 minus sine of x divided by 1 minus cosine of x, and we have to integrate that over the x variable. Wow. Well, I know that 1 minus cosine x will give us 1 minus cosine square x will give us sine square x. I will try to get a single denominator to see if I can cancel. Let's just do something, right? Let's multiply top and bottom by the conjugate of the denominator, all right? And then we will have the integral of e to power x, and then the numerator here, 1 minus sine of x, and the denominator is 1 minus cosine of x. Let's multiply the numerator by 1 plus cosine of x. So I say the conjugate of the denominator, and then we do that to the top and bottom so that we can just get 1 as a result, right? Good. And then by doing that, this would become e to power x times, so we're just going to expand the numerator and denominator. This will be 1 minus cosine of x, plus cosine of x, right? Minus sine of x, and then minus sine x, cosine x, and then at the bottom, right, since this is just the positive and the negative, the other terms are the same, I can rewrite this as a difference of two squares, that is cosine squared x. Good. And we put down the dx over here. Anyway, 1 minus cosine square x is just sine square x, so I can replace this denominator with sine square x, right? That is just a trig identity for cosine square x, or 1 minus cosine square x. Great. And then from here, well, should I cancel out some things? Well, let's just cancel out some things and see what we have. We have e to power x, and then 1 over sine square x is cosecant square x, alright? So we put down cosecant squared x, and then plus cosine x over sine square x. That is cosecant x, then times cotangent of x, right? If you divide this with sine squared, you know one of these signs can be pulled out. That will be 1 over sine, that will be cosecant, and then cosine x over sine x, that is cotangent. Great. And then negative sine x divided by sine square x, that will be negative 1 over sine x, that is negative cosecant x. And this last term here, we cancel out this with 1 of the sine. We have cosine over sine, which is just cotangent x. Good. And that is just the dx like that. Great. This is very long. Okay. This is very nice. Observe that the derivative of this cosecant gives us of this negative cosecant gives us the positive this, and then the derivative of negative cotangent x gives us cosecant squared x. So if I can rewrite this, the derivative of something gives you another thing. That means the integral of that other thing will give you the previous thing. Let's split these integrals into two parts. We're going to have, good. So we've got two different integrals here. E to power x with some stuff, and then e to power x with some stuff. I'm going to use the integration by part, right? And I'm going to use the DI method, or you can call it the table method, right? The DI method according to a BlackBerry pen. So maybe you can check out the videos. He has wonderful videos on this, right? But I'm just going to apply that right here. So I'm just going to put down DI. Okay, I'm going to do that for the two integrals. So let's see what we will have. We have DI, and then DI. Good. So first, I'm going to take out the first integral here. So I'm going to differentiate this. I'm going to integrate this. So I'm going to differentiate e to the power of x. And first, I have to remember to put down the signs plus and minus. Maybe I can continue alternating plus minus according to the DI method, right? And then this one, cosine this, the whole of that, I'm going to write it down. Cosecant squared x, then plus cosecant x, and then cotangent of x. So you want to differentiate this and want to integrate this one. Good. Again, we come over here. This is the second integral, right? This is a negative sign, but let's just deal with the function first. I want to differentiate this one and integrate this one. So I put down to differentiate. So the derivative of e to the power of x is just e to the power of x. Okay, that remains the same when differentiated and integrated. Then the integral of cosecant squared x is negative cotangent x, negative cotangent x. And the integral of this, cosecant, this and that, is going to give us negative cosecant, because that is what you get when you differentiate. You get this function when you differentiate negative cosecant. So if you integrate this function, you're going to get back negative cosecant x, right? Good. And you notice that this and this, they are the same. Okay, you just have to factor out a negative sign, right? So we are going to deal with that anyway. So let's differentiate this other part. When we differentiate cosecant x, we're going to have negative of, let me put it down, negative cosecant x times cotangent x, and then we differentiate cotangent x, we're going to have negative cosecant squared x. Good. So we are going to integrate the other part, e to the power x, that still remains the same, e to the power of x. All right. Now, to get this integral, we need to multiply, we need to compute this one, and then to get this one, we need to compute the other part, right? So let's multiply this out. According to the DI method formula, or procedure, we're going to multiply the diagonals, and then we are going to multiply this last row and integrate the last row only when we multiply it, all right? So we multiply this diagonal, we're going to have negative of e to the power of x times, this will give us cotangent x plus cosecant x. So you check that out. This and this has a negative sign. They both have a negative sign, so I'm going to factor out that negative, then multiply with e to the power x. And then the next thing we do here is to multiply this term together with this one. Okay, multiply the negative times the whole of that. That will be positive. Then we multiply with this one, and we integrate just that. So that will become positive integral of e to the power of x times cotangent of x, and then plus cosecant x. I put down the dx like that. Good. That is just for this part. So we're going to enter with this part now. So remember to put the negative sign, and then I'm going to take everything out here. Good. So again, we multiply the diagonal, and we multiply the last row and integrate it. So we multiply the diagonal, we're going to have e to the power of x times, and then multiply the last row, negative times the negative of this, that will become positive, right? That will become plus, and then I integrate everything there, e to the power of x, then cosecant cosecant, so multiply this, multiply that, cosecant x, cotangent of x, minus cosecant squared x, and we put down dx, okay? That is dx. Wow, this question is somehow. Anyway, let's close the blue bracket. Great. Let's see. We multiplied this with that, right? So I didn't close this bracket. I didn't put a bracket here. Right, that is nice now. So this negative this minus that, right? That will be negative 2 of those. And then, okay, so I'm going to have to clean up this part of the board, and then I'm going to rewrite this. The integral of this and that gives us this and that, right? So I'm going to have to expand these two things. Observe that this and this are the same. So taking out the negative of this, that will give us negative 2 e to the power x, then cosecant x plus cotangent of x. So you observe that this and this are just the same, and they both have a negative sign, so you subtract a negative thing from a negative thing. There are two of them are the same, so we just take this, and then this integral and this integral are different, so I'm going to have the integral of this minus this one, alright? Okay, good. That will become plus the integral of e to the power x, then cotangent of x plus cosecant x dx, and then minus the integral of this one, e to the power x, then cosecant x times cotangent of x minus cosecant squared x, and then we put down the dx like that. Good. It is very lengthy, but don't worry. So this is the left-hand side. We integrated this function, and we've gotten this. Remember, we had this, so I just had to simplify a little bit, and this is what we have. So it's like saying that the whole of this is equal to the whole of this, right? The whole of this equals to the whole of this. So I want you to see, we move this one to this side, right? They become plus. In fact, let me clean things up and rewrite everything for you to see. Right, great. So I've rewritten everything here. Now, these were the functions we arrived at after multiplying top and bottom by the conjugate of these, and then decancelling some things. We ended up with these two. So I had to separate the integrals. So we ended up with these two. And then after applying the DI method to this one and this one, we got up to this right-hand side. This term plus this one, right? Good. So as I've written it now, I want you to observe that this one and this one are the same, but they are opposite in sign. That is, this one is positive and this one is negative. And again, this one is positive and this right here is negative. So what I will do is to pull this one to the left-hand side, move this one also to the left-hand side, right? So you move this one to the left-hand side, it will become negative. But let's first of all move this one to the left-hand side. This is the equality sign. So moving this to the left-hand side, it will become positive. So we're going to have 2 of that, right? 2 times the integral. Let me bring it down a little bit. 2 times. So again, as I said, bring this one to this left-hand side to become 2 times that. 2 times the integral of e to the power x. And then cosecant squared x plus cosecant x cotangent x dx. Again, we're going to move this positive integral to the left-hand side to become negative, and the same as this. So we're going to subtract 2 of that, right? Because they are just the same. Then cosecant x plus cotangent of x. Good. And on the right-hand side, we just have this one left. That is negative 2 e to the power of x times cosecant x plus cotangent of x. Great. Okay, so let's see what we've got. We can divide throughout by 2, right? Divide throughout by 2. That will give us the left hand side. We just cancel 2 here, and then we cancel this other 2, and then that 2 we can cancel out with this one, and this is what we have as a result. Okay, cosecant x plus cotangent x. Cosecant is 1 over sine. Cotangent is cosine over sine. All in all, we have 1 plus cosine over sine. Right. Well, I think this is a nice place to end the video. So we just pause here and add an arbitrary constant plus c. So this is the antiderivative of that given function. Yes. Okay, so he's smiling right now. I say I'm correct. Wow. Okay, so that means I've finally solved the question. He said that is the antiderivative of that given function.
Happy birthday.